Good day everyone, my name is Grace Chava, an electrical engineering final year student at Central University of Technology. This is my presentation for my research question titled An experimental analysis of PIR-Triggered ultrasonic distance measurement in an Arduino-based smart home system. This project focuses on home security and automation. The research question for my project is: what is the maximum reliable distance at which an ultrasonic sensor can provide accurate results during PIR-triggered motion events in a smart home system? Before I explain my physical project, I would like to show and explain these posters behind me. This is my first submission, which was a proposal which clearly shows the project's name and the research question, the steps on how to build this project, and sensors. The first two sensors are the most important one to answer my research question, which is the PIR sensor and the ultrasonic sensor. In addition, there is IR obstacle sensor and DHT11 sensor. And then this is the list of all my components in my project. Arduino Uno, which is the central component, PIR sensor, ultrasonic sensor, IR sensor, DHT11 sensor, relay module, buzzer, servo motor, resistor, breadboard, jumper wires, ESP2866 Wi-Fi module, and LCD. And then this is my block diagram, which was my second submission. Here it clearly shows that the Arduino is the central component which controls all the sensors and other components. And on the left hand side, these are my inputs, and then on the right hand side, these are my outputs. And now this is my schematic, which shows the physical connection of my project. And then this one is the PCB, which shows how am I going to solder my project. And then lastly, this is my flow chart, which shows how my code it is going to run. Now I'm going to explain how this project is going to work. Okay, now I'm going to increase the distance by stepping back from this project, and the PIR sensor, each time I'm stepping back, the PIR sensor will detect my motion and the ultrasonic sensor will measure that distance. Meanwhile, the servo motor will lock the door when there is a distance that is being the motion that is being detected. And then in additional, but I won't be focusing much on it. I will show it once I'm done. The IR sensor, when I make an obstacle beneath this door, the door will lock and the LCD will display door locked on the first row, and then second row. On the first row, it will display obstacle detected. On the second row, it will display door locked. And the PIR, when it detects motion, the LCD will display motion detected on the first row, and then the distance measured by ultrasonic sensor on the second row. And then again, the buzzer will be emitted. And lastly, on normal condition, the DHT11 will display the temperature and humidity around this home. And on the first row, the LCD will display the temperature, and the second row will display the humidity. And now I will try to connect this project. Oh, before I connect the project, here is my research article, which again clearly shows the name of the project, the experimental analysis of PIR-triggered ultrasonic distance measurement in an Arduino-based smart home system. Okay, I am going to use this board that I'm holding, and each time I'm stepping back, I will show myself and then focus again on the LCD to see the measured distance. Okay, let me start making a motion now. It is 18 centimeter. I'm stepping back. It is 121 centimeter. I'm stepping back again. It is 204 centimeters. I'm stepping back again. Now I can see, but I think it is still 200 and something centimeters. I'm stepping back again. Okay, this is just about 400 centimeters. This is about 400 centimeters. Let me see if it will detect the accurate result. Now I'm on the 500 centimeters. Let me see if it will detect again. Okay. Now I will explain, but firstly I would like to unplug the buzzer, because each time I'm moving, the PIR sensor will detect me and the buzzer will be switched on by the relay. Okay, the specifications of this ultrasonic sensor, they say the ultrasonic sensor will provide 100% accurate measurements in a distance from 0 centimeters to 200 centimeters. But from 200 centimeters to 400 centimeters, the reliability deteriorates to 95%, which is still more or less accurate. But from 400 centimeters to from any values above 400 centimeters, the ultrasonic sensor, it is not reliable. So I will try to check the values and analyze them on ThinkSpeak now. As you can see, the ThinkSpeak shows that I was connected less than a minute ago. That means I am connected to ThinkSpeak. My ESP is working properly. Now let me check. These are the distances that I was detected on 216, and then again 452, and I was at the distance of 500. That clearly shows that the ultrasonic sensor, it is not reliable after the range of 400 centimeters. And again, I'm going to test if the IR obstacle sensor, it is going to work. The IR sensor, it is working. Here is obstacle detected, door locked. I would like to conclude this video by saying that through testing and data analysis, results showed that the ultrasonic sensor can provide accurate measurements within a range of 400 centimeters. Beyond this range, the measurements became unstable and provided false values. The system successfully proving that the maximum reliable distance for this ultrasonic sensor, it is 400 centimeters. Thank you for watching my presentation.